everyone. Today we will start new chapter modulation and demodulation and discuss about modulation. Without wasting any time, let's begin. Modulations, modulation, and we will see what is modulation, why it used in the communication, and what are the different type of modulations. So in a broad sense, communication is the exchange of information either wired or wireless between the 2 points which are far away from each other. So this information could be voice signal or email or even a television signal. But here let's take the example of the voice signal. So if we consider the speech signal or the human voice signal, then it contains the frequencies up to 3 kilohertz. And if we consider the entire audible spectrum, then it varies from 20 hertz to 20 kilohertz. So this low frequency or the message signal is known as the baseband signal. Baseband signal to a far distance, then there are some challenges. So we will talk about the challenges a little later. But the thing is, the baseband signal cannot be transmitted directly, but with the help of high frequency periodic signal it can be transmitted. So this high frequency periodic signal which carries the baseband signal is known as the carrier signal. But the question is how to impose this message or the baseband signal onto the carrier signal. Now we know that any signal has three basic properties, that is amplitude, phase and frequency. So the modulation is the process where one of the properties of the carrier signal like the amplitude, phase or the frequency is changed according to the baseband signal, and based on which property is changed there are different types of modulations. But before the first of all, let's see why this modulation is required. So the first reason to use this modulation is it reduce the antenna size. So when the signal is transmitted wirelessly, then the size of antenna is very important parameter. So the size of antenna is proportional to the wavelength of transmitted signal, and depending on the type of antenna it is the fraction of transmitted wavelength. So let's say the size of antenna is equal to lambda by 4. Now the relationship between the frequency and the wavelength can be given by the following expression. So for example, if the transmitted signal has a frequency of 10 kilohertz, then its wavelength will be equal to C upon F. That's equal to 3 into 10 raised to power 8 meter per second divided by 10 kilohertz. So if we calculate the wavelength, then it will come out of 3000 meter, and if the side alter antenna will come around as 7500 meter, and the size actually impractical, right? On the other hand, if the signal is transmitted at let's say 10 megahertz, then the length of the antenna will reduce by the factor of 1000. That means in that case the length of the antenna will be equal to 7.5 meter. And in fact the size of antenna is manageable, so that is one reason of for the modulation. Then the second reason is to reduce interference. So just imagine in a single room, if there three persons are talking in the same person, that person won't get anything right. Similarly, let's say if 5 different voice signal which are around in the same frequency range are transmitted without the modulation through a single channel, then there will be interference between them. We won't get the transmitted signal, but instead of that each signal is modulated and different carrier frequency, and all carrier frequency are relatively far away from each other. Then there won't be any interference, and all the signal can be demodulated, and the receiver and the messages signal of each transmitter can be retrieved. So using the modulation the interference can be reduced, and at same time the multiplexing of the different signal it also possible. And the example which I show you earlier is the example of the frequency division multiplexing, where the different message signal are modulated at different carrier frequency, and because of that they can be transmitted simultaneously. So these are some of important aspects why the modulation is used in the communication. So now let's see the different types of modulations. So broadly there are two types of modulations, analog modulation and digital modulations. So if the message signal is analog, then it is known as analog modulation, and similarly if the message signal digital form or in terms 1 second and 0 second, the digital modulation. So first of all, let's talk about the analog modulation. Analog, so based on type of carrier signal, this analog modulation can be further classified into two categories, that's continuous wave modulation and pulse modulation. So if we carrier signal is continuous wave signal like a sine wave signal, then it is known as continuous wave modulation. On the other hand, if the carrier signal of pulse signal, then it known as pulse modulation. And first of all, let's see the different types of